This here is 4096 bytes. So this must be a swarm chunk. But it's not. While it is true that one swarm chunk can hold up to 4096 bytes of data, it actually has an extra 8 bytes, the span. The span is a number stored in 8 bytes, which tells us how much data the chunk has. Not only does it make one chunk 8 bytes longer, but it also has an effect on the content address of a chunk. Before we make sense of these concepts, let's visit hash functions first. A hash function takes arbitrary data and turns it into a fixed length output known as the hash. For example, we can feed the hash function the text hello and get this. If we feed it hello again, we get the same hash. What if we change only a small detail, such as turning the H to uppercase? Will the hash change only slightly? As you can see, no, we received a completely different outcome. This property of hashing makes it secure and private and maps all distinct data to a uniformly distributed hash space. Also, hashing is one way only, unlike encryption. What if we feed the hash function some huge data? The output is still only 32 bytes because of its fixed length output property. In Swarm, and usually in the industry, we use the Kachak256 hash function. Remember this name. This here is a real Swarm chunk. It has 4096 bytes space, along with the span on the top correctly displaying 0 as we have not written anything to it. The 4096 bytes are grouped into segments of 32 bytes. There are 128 of them, as 32 times 128 is 4096. This will be important in a minute. Let's fill it up with some text data first. As we are writing it, you can see the span incrementing one by one as we are using up those byte slots. Now let's talk about the elephant in the room, the address of the chunk. As you know, Swarm chunks are content addressed, meaning their address is deterministic based on their content, and they are located using their address. How can we, or how does B, calculate the corresponding address given some data like we have here? Let's bring in the Kachak256 hash function we discussed earlier and calculate the so-called BMT root hash of this chunk. I will show you the process, it's not that bad. First, we hash every segment with its pair, which is the one after it. That is, we feed the Kachak256 with the bytes in the first segment and the bytes in the second segment. We repeat this step until there is only one hash left. Once we are down to 1, we have the root hash. But is it the address of the chunk? Not yet, but we are almost there. Let's convert the span, the length of the chunk, to a little endian unsigned int 64. It is one way to represent a number in binary format. It is no longer readable for us mortals, but it's still the same number. Finally, we hash together the span and the root hash, which gets us down to only one hash again, the final hash. This is the address of the chunk. It's EF something ending with 7A. Don't take my word for it, let's upload the original text to a live B node and check what hash we get. Also EF something ending with 7A. Thank you for your attention.